Dear students, this is Sivaganappa Physics lecturer from Minority Moraji Desai Residential PU College, Raichur. Dear students, in this video we are going to teach that is properties of electric charges. This is very important in a PU board for 3 marks. Okay, so now we are discussing all the properties with one by one. The first one is conservation of the charge. First one is conservation of charges. Conservation of charges. First, what's the meaning of conservation of the charge? Okay, that is a total charge of an isolated system is always constant. Total charges in the given system remains constant. That is a conservation of the charge. So here charges cannot create as well as cannot destroy. They simply transfer from one body to the another body. Okay, clear? Total charges in the isolated system remains constant. Charges cannot destroy or cannot create. They simply transfer from one body to the another body. That is the conservation of the charges. For example, here we consider this is one of the glass rod. This glass rod having 10 protons and 10 electrons. Total number of charges in the glass rod, how many here? 20. Similarly, we consider this is silk cloth. Silk cloth. In this silk cloth also we have proton is 10 and electron is also 10. If we consider this is the one of the system, total charges remains constant. How many charges are there in this system? Here 20, here 20. Totally we have 40 charges. Just for understanding purpose, totally 40. If this glass rod which is rubbed with a silk, at the time the glass rod which is loses the electron and silk it will be gains the electron, right? So it loses the electron. 5 electrons if they are moving towards the silk cloth. Okay, how many becomes here? Here electrons is 5, totally 15. Here 5 electrons are remains. But charges cannot destroy or cannot create. They simply transfer from one body to the another body. Then total charges remains constant. Clear? Okay, this is conservation of the charge. Then second one is additive of the charges. Second one is additive of the charges. Additive of the charges. Okay, so first we have to understand what's the meaning of additive of the charge. The total charge of the system is equal to algebraic sum of the charges. Algebraic sum of the charges is called additive of the charges. For example, here we consider one of the system. This system consists of this Q represent total charge. This system consists of number of charges like Q1 and minus Q2 and Q3 and minus Q4. The total charges for this isolated system is Q1 minus Q2 plus Q3 minus Q4. This is additive of the charges. So just you can consider one of the example. Any one of the system is consist charge that is Q1 is 2 coulomb, Q2 is 1 coulomb and Q3 is this is minus 1 coulomb. Okay, so then we can calculate total charge that is Q is equal to Q1 is 2 and Q2 is plus 1 and Q3 is minus 1. Plus 1 minus 1 get cancelled. Total charges in the system is 2 coulomb. 2 coulomb. This is right. This is 2 coulomb. So this is explanation about additive of the charges. Another property, that is quantization of the charge, now we are discussing. That is quantization of charge. Third property. Okay, third property is that is quantization of the charge. Third property, quantization of the charges. Quantization of the charges. Okay, so what is the meaning of quantization of the charge? So all the charges, or charge on a body is equal to integral multiple of the basic unit of the charge, is called the quantization of the charge. Any body, it contains the charges is equal to, that is integral multiple of the basic unit of the charge, is called the quantization of the charge. Okay, so here we have the formula for quantization of the charge, that is Q is equal to plus or minus N into E. This is very important formula. So they can ask one more problems also in this problem, in this formula. So clear? Are you understanding? That is what is the meaning of quantization of the charge? So the total charge on a body, is equal to integral multiple of basic unit of the charge, is called the quantization of the charge. Here the quantization of the charge, we have the formula, that is Q is equal to plus or minus N into E. Here where Q is equal to what? We can represent it, this is the capital Q or small q, we can represent like this. Here capital Q represents total charge, and N represents, this is integer numbers 1 comma 2 comma 3 comma so on. Then E represents charge of the electron, its value is 1.6 into 10 to the power minus 19 coulomb. Here always we can consider charge of the electron, that is minus 1.6 into 10 to the power of minus 19. Like this, charge of the proton is also, it's a positive, same value, that is 1.6 into 10 to the power minus 19 coulomb. This is the charge of the proton, but charge of the electron we have to represent this is negative. You can consider in terms of magnitude this way. You can take E is equal to 1.6 into 10 to the power minus 19 coulomb. This is quantization of the charge. We can see some problems, how they can ask the problems on quantization of the charge. Now just I take one problem. How many electrons will take to charge of 1 coulomb? The question will be asking like this. Just take one problem. Here, see here. How many electrons will have total charge of 1 coulomb? The question which is like this: how many electrons will have total charge of 1 coulomb? Right. So here they are given Q here, that is 1 coulomb. Okay. N we have to find out, because how many electrons, number of electrons we have to find out, but we don't know. That's we have the formula, right? That is Q is equal to plus or minus N into E. Just I said, that is, if I take here the capital or small q plus or minus n we have we have to find out this n value, that is n is equal to q divided by e, right? So we don't know value this, right? We have the standard value. This is charge of electron, that is 1.6 into 10 to the power minus 19 coulomb. Therefore, we can take value E is equal to 1.6 into 10 to the power minus 19 coulomb. Just we can simplify here. N is equal to 1 divided by 1.6 into 10 to the power minus 19 coulomb. So total we getting answer here. N is equal to 6.25 into 10 to the power plus 18 electrons. How many electrons are present in 1 coulomb of the charge is 6.25 into 10 to the power 18 coulomb. This is answer for this. Like this, they can ask different questions in this. There is a quantization of the charge formula. The Q is equal to plus or minus Ne. Also, we can see another problem here. See another problem. The question is a charge. Next, second problem is a charge of 4.5 into 10 to the power minus 19 coulomb possible. Okay, is a charge of 4.5 into 10 to the power minus 19 coulomb is possible or not? You have to just say it's possible or not possible. Okay, so here in this they are given Q is equal to how much, that is 4.5 into 10 to the power minus 19 coulomb. E we know the value, that is 1.6 into 10 to the power minus 19 coulomb. Then we have to find out n value, right? That is n is equal to, just we can written here, that is n is equal to q by E. Then this is q value is 4.5 into 10 to the power minus 19. And here 1.6 into 10 to the power minus 19. Minus 19 get cancelled. 4.5 divided by 1.6, it n value becomes here 2.8 electrons. It's not possible, right? The n value having fraction. How to get the n values? Numbers, that is integer numbers, that is 1, 2, 3, 4, 5, 6, 7, 8 like this. But here we getting fraction number here. That is 2.8, 2.5, 2.6 is a fraction number. So not possible. Therefore, for this problem, it's not possible because of 2.8 value. 2.8 value is, it is in terms of fraction. Okay, it is another property of electric charges. Like this, we have number of problems can solve in the next videos. Just here we are discussing simple problems here. Next property of electric charge. Electric charge, that is fourth property. So here, like charges are repels and unlike charges are attract, right? If we consider here, like charges are repel, and unlike charges are attractive. Okay, unlike charges are attractive. Let us see here. So one of the charge, that is Q, having positive, and this Q1 is positive, and Q2 is also positive. So these two charges are same sign. This is positive, this is positive. The four charges are, they get some repulse. If we consider one charge is negative, another charge is positive, they get attract each other. They get attract because of opposite sign. These are having opposite sign. This is also one of the property. The like charges are repulse and unlike charges are attract. Then another property, that is fifth property. Okay, charges always reside over the surface of the conductor. ಹೌದಾ, ಚಾರ್ಜ್ಗಳು ಯಾವಾಗಲೂ ಏನಾಗಿರ್ತಾವ ಅಂದ್ರೆ ಕಂಡಕ್ಟರ್ ಒಳಗಡೆ ಇರಂಗಿಲ್ಲ. ಆ ಚಾರ್ಜಸ್ ಯಾವಾಗ ಎಲ್ಲಿರ್ತಾವ, ಸರ್ಫೇಸ್ ಮೇಲೆ ಕುಂತ್ಕೊಂಡಿರ್ತಾವ ಚಾರ್ಜಸ್. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇದನ್ನಂತ ಏನಾದ್ರು ಕಂಡಕ್ಟರ್ ಅಂತ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಿಕೊಂಡ್ರೆ, ಚಾರ್ಜಸ್ ಆಲ್ವೇಸ್ ಪ್ರೆಸೆನ್ಸ್ ಓವರ್ ದಿ ಸರ್ಫೇಸ್ ಆಫ್ ದಿ ಕಂಡಕ್ಟರ್, ಓವರ್ ದಿ ಸರ್ಫೇಸ್ ಆಫ್ ದಿ conductor only. The charges does not presence inside the conductor because it says that its property only charges reside over the conductor only. Charges ಗಳು ಯಾವಾಗ ಏನಿರ್ತಾವ ಕಂಡಕ್ಟರ್ ಮೇಲೆ ಬಂದು ಕೂತ್ಕೊಂಡಿರ್ತಾವ ಸರ್ಫೇಸ್ ಮೇಲೆ ಹೊರತು ಸೊ ಕಂಡಕ್ಟರ್ ಒಳಗಡೆ ಇರೋದಿಲ್ಲ. ಇದೊಂದು ಪ್ರಾಪರ್ಟಿ ಅಂತ ತಗೊಂತಾ ಇದೀವಿ, ಫಿಫ್ತ್ ಪ್ರಾಪರ್ಟಿ ಅದು. ಸೊ ದೆನ್ ಸಿಕ್ಸ್ ಪ್ರಾಪರ್ಟಿ, the charge is a scalar quantity. Charge is a scalar quantity. Charge is a scalar quantity. We know what is the meaning of scalar? What is the meaning of scalar? Which is having magnitude but not direction. Okay. So sixth property is charge is a scalar quantity. Charge is a scalar quantity. Scalar quantity because it has magnitude but not direction for the charge. Therefore, we can say charge is a scalar quantity. Then, next property you can see some more properties. When the charge which is rest, if the, for example, seventh property, if this is one of the material. In this material we have the number of charges are accumulated in this body. At the time charges should be at state of rest. When the charge is rest, it produces electric field surrounding itself. Okay, right. For example, if this is the charge which is present in the space, surrounding of that charge, it produces electric field lines. Electric field. When the charge it produces electric field line when it should be at rest. So further concept we discussing when the charge is moving, that is a magnetic field which is producing and current, all those things we discussing, right? But in this concept we going to discuss that is the chapter electrostatic. Therefore we are discussing only regarding charges should be rest. When charge is rest, it produces electric field. Charge is rest. Charge is rest, it produces electric field surrounding itself. This is also one of the property. So dear students, these properties are very very important for exam point of view. So pure board exam point of view. So all of you are ready to memorize this. The first property we are discussing, right? That is conservation of the charge. Second one is additive of the charge. Third one is quantization of the charge. Fourth one is like charges are repels and unlike charges are attract. Charge is a scalar quantity. So why we consider that is a scalar quantity? Because it has magnitude but does not having any particular direction. And last one is charge. When the charge is at rest, it produces electric field. Okay, so these are all some important basic properties of electric charges. Okay, you have to remember at least 3 or 4 major. You have to remember here: conservation of the charge, additive of the charge, and quantization of the charge. And like charges are repels and unlike charges are attract. You have to remember at least 4 if they are asking for 3 marks. Okay, thank you for watching this video. Thank you.